Good evening. My name is Vishwanath and I'm speaking to you from Bangalore in India. Let me present my case study on rainwater harvesting in India with special reference to the state of Karnataka, and I shall present a rural and urban case study. For more details, you can go to my website rainwaterclub.org, and I urge you to become members of the International Rainwater Catchment Systems Association, which is www.ircsa.org, which will give you a lot of information and knowledge on rainwater harvesting practices all across the world. We are in a water scarce world where there is global warming and climate change, and in many of the arid and semi-arid countries, every drop of water is precious, as is depicted in this beautiful big sculpture in China on the banks of the Yellow River. Save every drop. What then is rainwater harvesting? It's the process of collecting and storing rainwater for future productive use. Now, the storage could be in drums or in underground sump tanks or over the ground tanks, or it could use the earth as a store whereby we recharge the aquifer. So this is called artificial recharge or aquifer recharge. A rainwater harvesting system essentially consists of a catchment, which could be a roof generally, a conveyance system, gutters or pipes, a filtration system to remove organic material and silt from the rainwater, and finally a storage or a recharge structure. These components comprise a rainwater harvesting system. In India, rainwater harvesting has had policy recognition both at the national level and at the state level. At the national level, the water policy says that the efficient utilization of water and the use of rainwater harvesting and water conservation will be encouraged. This will be promoted through education, regulation incentives, and disincentives. This policy is now being rolled out in almost all the states of India. Let's talk about rural rainwater harvesting. In the state of Karnataka, where I come from, rainwater harvesting system from rooftops in brick masonry tanks of 2,000 liters capacity has been implemented in 1,000 villages, with about 20 households in each village adopting this system. So 20,000 such structures have been put. There's also been a very large school-based program where all rural schools, 23,683 of them, have had a rainwater harvesting system of between 5,000 to 8,000 liters storage capacity to provide additional supplemental water for students. And particularly in fluoride-affected areas where the groundwater is contaminated with fluoride, rooftop rainwater harvesting structures have been put in place, which store between 5,000 and 8,000 liters of water at the household level. And this provides to the family 20 liters per day of water for the whole year. This water is free from fluoride and any contaminant, and therefore prevents the occurrence of fluorosis. This has been one of the most successful rooftop rainwater harvesting systems in our state. Rainwater harvesting has been traditional in India. A simple system is using a cloth, which is the catchment, a conveyance, a filtration system, and the pot is the storage. And if it rains for 180 days, in a year, 180 days of water supply for the family is met by the simple system. The more structured system is what you can see in this photograph, where rooftop rainwater from an asbestos sheet roof is collected in plastic pipes, brought down. There's a first rain separator, there's a small sand filter, and a storage tank of about 2,000 liters. This has been adopted, like I said, in about 1,000 villages and in about 20,000 households. There are simple checks available for checking the rainwater for E. coli presence, the presence of bacteria harmful to human beings. The H2S vial test is a simple test where you put rainwater into the bottle, observe for 36 hours, and check whether the water bottle turns black or brown. If it stays brown, as in this picture, there is no E. coli contamination. If the bottled water turns black, there is E. coli contamination, and further purification has to be resorted to. The purification can be as simple as SODIS or solar disinfection, where you put the water into a plastic bottle, a PET bottle or a glass bottle, leave it in the sun for 5 hours. The exposure to UV rays and infrared rays eliminates most E. coli and coliform bacteria. Let us look at rainwater harvesting in the city of Bangalore. At the city scale, rainwater is collected in many tanks and lakes and allowed to infiltrate into the ground and recharge the aquifer. At individual buildings, each rooftop can harvest rainwater and store it in a sump tank or recharge into the aquifer. I will explain the process adopted in the future slides. This is the schematic diagram for how rainwater harvesting is managed at a city level. Rooftop rainwater is filtered and stored usually in underground sump tanks. It could also be recharged into the ground. Water from parks and landscaped areas is filtered and usually recharged into the ground. Finally, water from major stormwater drains is filtered through a biological process and collected in the many lakes and tanks that we have in the city, which eventually also goes towards groundwater recharge and soil moisture enhancement. This is the broad schema of rainwater management at a city level. A local hydrological cycle level indicates that before a building comes on a plot of land, there is much evapotranspiration, some amount of surface runoff, some amount of groundwater recharge. But once a building is put on a lot or on a plot of land, this is what happens. The surface runoff increases from 15% to 90%. The recharge of groundwater drops from 10% to about 5%. And evaporation or evapotranspiration drops from 75% to 5%. The overall objective of rainwater harvesting would be to go back to this particular levels so that there is no damage to the city through flooding. A simple way is to put a rain barrel and collect rooftop rainwater in this barrel, have a tap, put a filter on the tap, and use the water for non-potable purpose. This is the simplest system of rainwater harvesting. The new law for Bangalore states that for every plot or every building, 20 liters of storage or recharge has to be created for every square meter of roof area. Similarly, for the paved area around the building, 10 liters of storage or recharge has to be created for every square meter. For non-paved area, there is no need to do any rainwater harvesting. For recharge, a minimum depth of 3 meters is recommended for the recharge well. How do you harvest rainwater? Well, obviously you start by training plumbers in designing and implementing systems. You understand the rain, you do a cascade capture, you try to capture water at the highest possible levels, and finally you do groundwater recharge. Aesthetic systems of rainwater harvesting by bringing water down chains and allowing it to go into a recharge well is also possible. It is useful to understand the rainfall pattern in the city. In our city of Bangalore, we have 970 millimeters of rain with a bimodal peak, a peak in the month of May and another peak in the month of September. A well-distributed rainfall pattern with 60 rainy days permits easier storage and recharge system. The maximum rainfall intensity is 90 millimeters per hour, which also provides useful design criteria. Every roof in the city can be designed to be clean and to be a catchment. There are 1.5 million roofs in the city of Bangalore. Every roof in the city can be designed as a catchment, and if it's kept clean, the quality of harvested rainwater will be very high. This is what citizens are being encouraged to do. From the rooftop, the water is brought down pipes and through a filter and stored in underground tanks, as you can see in this photograph. A bit more detail, the vertical pipe has an end cap which can be opened when the roof is being cleaned or when water is not to be harvested. When the water is to be harvested, the cap is closed so that 2 millimeters accumulates in the vertical pipe, then comes down to a ferrocement filter which contains sand. The sand acts as a filtering medium and keeps the organic material out and allows clean water to go into the underground sump tank. These sump tanks, which are below the ground, are usually about 6,000 liters in capacity, and they can harvest very clean water. There is another system of rainwater harvesting, which is to pick the roof water and recharge the ground. Once a recharge area is identified, we need to dig into the earth to reach a more porous area. Bypassing the clay layer, the pit is dug to reach weathered rock or porous earth. And then large stone is filled. Usually these pits are about 3 meters to 4 meters in depth. Large stones are filled at the bottom, followed by smaller stones, and finally coarse sand at the top. It is then finished and level with the earth, and the earth is sloped so that all the water falling comes to the sand as runoff. The runoff is filtered through the sand, large stones and small stones, and goes into the aquifer. Recharge pits can also be made around the bore well and boreholes, and the same method is followed for recharge. Another method which is more popular than the recharge pit is something called the recharge well, where you dig typically 6 meters deep through the clay soil and reach the more porous soil and line the pit with concrete rings. The concrete rings are slowly being placed inside the pit. At the top of the concrete ring, a concrete slab will be placed or steel grills can be placed. A silt trap is made in the storm drain to capture the silt, and water would go into the recharge well. As you will see, rainwater and stormwater goes into the recharge well. Rates of recharge of over 6,000 liters to 10,000 liters per hour has been observed in the recharge wells, which function as excellent recharge structures for the aquifer. Recharge wells can be located next to stormwater drains, smaller stormwater drains, and a bypass made to divert the stormwater into it. Once we understand the rates of recharge of each well, a series of recharge wells can be placed next to stormwater drain to make the site a zero runoff area, and therefore to enable vast volumes of water to enter the aquifer. It is important to maintain the stormwater drains cleanliness and ensure that only clean water goes into the recharge wells. These act as stores during the rainy season and can be drawn upon in the summer months when water is scarce and short. Recharge wells can also be located in the stormwater drain itself, thus occupying very little space, provided a silt trap is made and a mesh is put so that clean water gets into the recharge well. This is a beautifully designed recharge well which picks rooftop water and is integrated with the landscape of the building. This acts both as a store during the rainy season and as a drawal well during the non-rainy season. We need rainwater harvesting through all methods in both rural areas and urban areas, and I gave you a glimpse of the way it is practiced in the state of Karnataka. We need to do this for the blue planet that is ours, and I welcome you to the city whenever you have the time for you to be shown what is happening with the help of the citizens of the state of Karnataka and the city of Bangalore. Thank you for your time and patience.